Welcome to Python 101, the basics. Hi, I'm Bill Weinman. Python is an immensely popular programming language. It's used for web applications, scientific computing, machine learning, data analysis, systems, and business applications. Its simple syntax and quick development cycle make it especially easy to learn. Many systems come with Python already installed, or you may download and install the latest version of Python from the python.org website. If you want to write Python code, you'll need a good development environment. Visual Studio Code from Microsoft is an excellent Python environment, and it's available free from code.visualstudio.com. This is a very simple Python script. The first line is a comment. Comments in Python are introduced with a hash symbol. The second line prints the string hello world. Print is a built-in function, so this statement is called a function call. It calls the print function and passes the string as an argument. Here's another version of the same script. On line 3, we define a function called hello. The body of the function is indented. This is called a block of code. Python uses indents to distinguish a block of code. On line 6, we call the function. This executes the code in the body of the function. Let's learn a bit more about the anatomy of a Python script with a few clips from my Python Basics course. This is hello-version.py from chapter 1 of the exercise files. Comments are introduced by a pound sign or a hash mark. And so you can see these are both comments. These first two lines are both comments because they're introduced by that hash mark. The first line is a special case of a comment. It's called a shebang line or sometimes hash bang. And this has significance on Unix systems. And of course, this Mac is a type of a Unix system. It's based on Berkeley Unix. Your Windows system will ignore this line because it has that hash mark, so it's interpreted as a comment. And so it's always a good idea to include the shebang line, and I'm going to explain that right now. The shebang line is a common pattern for Unix systems. It allows a script to be invoked from the command line. There are two parts to the shebang line. The hash and the exclamation mark must be the first two characters on the first line of the file. These marks together form the shebang. An exclamation mark is sometimes called a bang, so hash plus bang is where the word shebang comes from. There must be no lines before this line and no spaces before these first two characters. Essentially, these first two characters must be the first two bytes in the file. After the shebang is the path to the executable that will run your script, along with any optional arguments. In this case, we're using the Unix env command, env, to find the path to the Python interpreter. This is a common usage. Alternately, we could use the absolute path to the Python interpreter. I don't use this method because these example scripts must operate on different installations, and I cannot predict the path of the Python interpreter on different systems. So for our purposes, I use the env command, the env command in the examples for this course. Following the comments, the first line in the script is an import statement. This tells the Python interpreter to import a module from the library. Platform is a standard module which is included with the Python interpreter. After the import statement, you'll find the rest of the script. This is an example of a conditional statement in Python. If the condition evaluates as true, then the statement block will be executed. The statement block may be one or more statements indented under the if condition. The if statement is the simplest form of conditional. When the condition is evaluated, it's found to be either true or false. If the condition is true, then the indented statement block is executed and flow continues after the conditional. If the condition is false, then the flow continues after the conditional without executing the indented statement block. An if statement may also have an else clause, which looks like this in Python. Notice that there's a separate else statement block for the else condition. This block of statements is executed if the condition is evaluated as false. The if-else construct works like this. If the condition is true, then the statement block is executed and flow continues after the conditional. If the condition is false, then the else statement block is executed and flow continues after the conditional. In either case, one and only one of the blocks of statements will be executed. This is blocks.py from chapter 2 of the exercise files, and down here you see we have an if statement. The condition is this x is less than y. If x is less than y evaluates as true, then this print call will happen, and if not, we'll continue after that block. And I'm just going to put a print statement here that says after the conditional. And when I run this, you'll notice that this print statement happens. It says true, x is 42 and y is 73. And also this statement happens, which prints after the conditional. If I change this condition so that it evaluates as false, I'll just make that a greater than instead of a less than. And now x is greater than y will evaluate to false because x is 42 and y is 73. And I'll go ahead and I'll run this, and you see we just get the after the conditional. Execution skips this statement block and instead just continues out here. I can add an else, and I can just make a copy of this, and we'll just say false. And when I run this now, we'll get the false statement because the condition evaluated as false. There is one more clause we can add to this, and it's called elif, and it looks like this. And I'll just put this statement in here, and I'll just say elif y is equal to 73. I don't want to make that lowercase just for consistency. And we don't need the F here because we're not interpolating anything. And now when I run this, you'll notice that it says that the elif block is executed. And I can have a few of these, right? I can have one that's 74 and one that's 75. And this works as expected. If I change y to be 74, then we get the elif. Oh, let me change these so we know which one it is. And I'll run it again. It says y is 74. And if I change y to be 75, then we get the y is 75. And if I change y as 76, we just get the false condition because none of these evaluated to true. So the if statement has really two different additional clauses. We have elif, which can test for alternate conditions, and we have else for when none of those conditions evaluate as true. And all the elifs need to go between the original if and the else. This is class.py from chapter 8 of the exercise files. Here we have a simple class definition. It starts with the class keyword followed by the name of the class and a colon. You'll notice that the name of the class has an initial capital letter. This is traditional. It's traditional to name a class with an initial capital letter. It's not required, but it is traditional. And this class is named duck. And then everything that belongs to the class is indented under the class definition. We have data, two variables, sound and movement, and we have functions. Functions in a class are called methods. And they work just like a function, except that they belong to the class. So we use the def keyword, we give it the name of the function, and we give it arguments in parentheses. Arguments are parameters. The first argument is required, and it's traditionally named self. In fact, it is so common to name it self that if you name it something else, you will confuse people. So always name it self. And that first argument refers to the object that is created or instantiated from this class. And so when you create an object from the class, this self argument will point to that object. And then down here in main, we create an object from the class. And we call the object Donald. So the object is Donald and the class is duck. And the parentheses are there to indicate that we're using the class to construct an object. We refer to members of the object with the dot operator. And so here we're calling the quack method on the Donald object using the dot operator. And here we're calling the move method with the dot operator. Just like inside the class, using the self variable, which refers to the object, we can refer to the sound data member using the dot operator. So that's how all of that works. And we'll get into a lot more detail as we continue in this chapter. Let me just run this so you can see what happens. Here we have constructed the Donald object. We've called quack, and so it says quack, quack. See, the quack method prints self sound, and sound is quack, quack. And we call move, and the move method prints the self.movement data member, which says walks like a duck. Get started coding Python with my complete Python basics course, available at the link below. And happy coding.